When you ask where does the needle point on a compass, the answer isn't just north. See, there's a difference between magnetic north, which is where your compass points towards, and true north, which is towards the North Pole. Not many people have heard of declination, but its importance in the field of surveying is difficult to understate. According to the Merriam-Webster dictionary, the definition of declination is the angle formed between the needle of a compass and the true meridian. Not very specific, but it's a good start. These lines drawn over the map of the United States represent the Earth's magnetic field, and the lines are called declination lines. As you can see, they're not straight, they're bent, and they all condense here towards the Great Lakes. This line is referred to as the agonic line, or the line where true north matches up with magnetic north. So when surveyors, or even people trail hiking or doing construction, take a compass reading, they have to account for their compass pointing at some angle east or west of true north, unless they're very close to the agonic line. Here in Georgia, we can see that the angle of declination is somewhere between 0 and 5 degrees to the west. But that's the problem, isn't it? It's somewhere between 0 and 5 degrees. It's not necessarily exact. See, declination can be fairly hard to nail down. And for many purposes, like trail hiking, we hardly have to account for it at all here in Georgia. But many professions, like surveying, have to be extremely precise in their measurement, precise to the foot when measuring miles. Many locations have published declination values, measured so that surveyors can be as accurate as they reasonably can. For example, in Marietta, Georgia, the Kennesaw heliport is published as 5.26 degrees west in declination. But hold on, Georgia is supposed to be between 0 degrees and 5 degrees to the west, so why is it greater than 5 degrees to the west? We're seeing the effects of a couple phenomena when we look at that. Lots of things affect magnetic declination, much more than just the Earth's magnetic field. One major cause of localized declination is the presence of underground iron ore or magnetite deposits. Other things that can affect the accuracy of your compass are metal fences, power lines, and even parked vehicles. Believe it or not, those things can put a sizable impact on the accuracy of a compass reading. And declination also changes with time. For example, that same point, the Kennesaw heliport, has a recorded annual declination shift of 0.07 degrees.
We discussed what declination is conceptually, but how do we apply it? A compass has 360 degrees, like any circle, and it's counted clockwise starting at north. When accounting for declination, values east of true north will add to your compass reading, and values west of true north will subtract from the compass reading. When correcting compass readings for declination, you reverse its effects by performing the opposite operation. I'll show you what I mean with an example. We want to know the true bearing or angle from our location to the peak of this mountain in Dalton, Georgia. This blue arrow represents magnetic north as shown by the point of our compass needle. And this red arrow is a straight line from where we are standing to the peak of that mountain in the distance. The compass reading reads north 60 degrees east, based on the angle between magnetic north and the angle to our object that we're trying to locate. The declination in Dalton, Georgia is 5 degrees, 9 minutes, and 0 seconds west as of 2021. This compass reading still has declination error, so we need to correct it. West declination values subtract from our compass reading, which is the opposite operation of adding. So that's what we'll do to correct our value. You take our compass reading of 60 degrees, add 5 degrees and 9 minutes, and come up with 65 degrees and 9 minutes. So the true bearing from our location to the peak of that mountain is north 65 degrees, 9 minutes east.
Our resident surveying expert here at KSU, Daniel Branham, has some interesting experience with declination in North Georgia. So Professor Branham, tell us briefly about what declination is and how it applies to the field of surveying.
So, in effect, the true essence of declination is the angle between true north and what is commonly referred to as magnetic north. That angle can vary from 0 degrees, where true north and magnetic north coincidence, or it can vary up to as much as 30 degrees east or west of true north. So declination is that angle variation between actual true north and the magnetic north. And the most common way of measuring north is using the compass. And the compass is magnetic by nature, so therefore we're measuring magnetic north when in effect what we really want to know is where is true north, because true north never changes. Magnetic north is constantly changing.
Right, true north is just a straight line from where we are to the North Pole of the Earth.
To the geographic location of the North Pole on the Earth, not to the theoretical location of it, because the magnetic location is constantly changing.
So, have the effects of declination impacted your surveys over the course of your career?
They have for a good part in the early part of my career when I was surveying up in West Virginia, where declination is really something that is measured and recorded on a regular basis. Coming to Georgia in the early 80s, it wasn't that big of an issue because Georgia doesn't really require us to deal with declination, even though declination exists regardless of where you're at, not just in the United States, but across the entire globe. So therefore declination applies regardless of where you're at. It's just different areas have different rules and regulations, and Georgia doesn't have anything that specifically states you need to observe and record declination at the time you're doing the survey you're currently doing.
I see. So that's something that might be different state to state.
It definitely is different state to state. In West Virginia, where I originally came from, it is required that you measure declination at the time of your survey, and you record it on your survey drawing so that the surveyor that follows in your footsteps later on, that comes behind you to retrace the survey that you prepared, will be able to look at the declination that you had at the time you did the survey at time A, and when he's redoing the survey at time B, he can apply the difference in declination and therefore travel the same line that you traveled at time A.
That makes a lot of sense. So can you give an example of a time, of a specific time when declination had an unexpectedly large impact on your survey?
When I first came to Georgia in the early 80s, I was working for a surveying company, and I would just work in the field doing actual physical surveys. Then after about a year and a half of working for that company, I changed and went to work for another company where I moved more into a managerial position, and I was in charge of multiple crews and the jobs that they had to do each day. So I had sent a crew to do a survey in the downtown Atlanta area, where the majority of downtown Atlanta is laid out in north-south or east-west directions. Most streets are laid out that way in the old section of the town. And they were surveying a piece of property that was fairly rectangular in shape, but it was really overgrown, and there was very little evidence of possession, no fence lines or anything to that effect. And starting at the first point where they thought the property corner would be at the road, they used a compass to kind of get an idea of where to go back in the woods to look for the back corner once they had pulled the distance. And let's just say that the distance was 500 foot. When they pulled that distance back, they couldn't find any evidence of the property corner. So they went back to the street, and they went down the street to the other property corner that would be at the street, and they did the same thing with their compass. And they took that site to go back, and they again didn't find any evidence of the property corner. Problem was is they weren't accounting for the fact that the original survey was done roughly in 1880. So like 110 years prior to that, when the survey was done, declination was maybe 5 or 6 degrees different than it was at the time my crew was trying to do the survey. So when I went out there, I looked at the bearing from the past, and I used the current declination, to convert the bearing from the past to its true bearing in the past, and then the true bearing in the past to the current magnetic bearing using today's current, or that day's current declination. And I was able to take that same compass and adjust that bearing by roughly 5 degrees and pull that same distance back, but wind up 20 or 30 feet in a different area and look for that corner and successfully find it. So I proved to the crews that it's important for them to start thinking about the deviation of the magnetic north needle from time A to time B. And 110 years is a long time. So over the course of a year or two, it might not change very much. It might be minutes of a degree. But over the course of 100 years, we're talking 4, 5, 6 degrees, depending upon the location and the latitude and longitude where you're doing the survey.
So, is it easy to account for in most cases, or does it prove challenging a lot of the time?
Where it's been recorded on the survey, when the person that originally surveyed the property, if he records what the declination was at the time he did the survey, then it makes it easier for the person that comes after him because he knows what he's looking for. He knows how to make the adjustment. It's the drawings that don't have the old declination on them. So therefore, the surveyor doesn't even consider the fact that the declination may have been an issue, and therefore they don't apply the rules.
So it's a pretty routine formula to account for it when it's recorded before
Very
you.
simple, yeah, very simple. If the person before you took the precautions of recording the declination at the time he did the survey or she did it, so that you can apply the corrections when you come after them.
So if they didn't record it, you might have to do some research and figure out what your adjustment needs to be.
That's true. So all these all these declinations have been recorded over the course of hundreds of years in the United States, back to the 1700s. So these declinations for various areas have been recorded and archived, so you can research and find out what the declination was. As long as you pay attention to the drawing and see what year it was drawn in, you can find the declination even if somebody didn't record it on their drawing.
So has technology made declination less of a concern for the field today, or is it still very relevant?
Yeah, technology's definitely done away with the necessity of dealing with declination, just for the fact that everything is using GPS now. Even the newer surveying instruments all are based upon GPS. The constellation of satellites is so vast that you can get a GPS signal basically any time that you're out there doing the work 24 hours a day now. It used to be there were certain hours of the day that you would have to do a GPS observation. Maybe from 10 o'clock in the morning till 2 o'clock in the afternoon was the optimum time on the day you were going to do a survey. That would be the only time that you would know there would be enough satellites overhead that you'd get good GPS lock and you would know where you were at. But that was back in the 80s, the early 80s. By the advent of the 90s, we got up to roughly 36 or so geosynchronous satellites that were sending GPS signals down. So it became more redundant. Sometimes you'd have 5 satellites that were over top of your receiver, sometimes as many as 10 satellites over top of your receiver. So now it's really simple to come up with true north, and we've basically done away with using the compass to find the line. We're using the compass to retrace the old lines. But the history is the country's roughly 250 years old. So we've got 200 years of surveying history, plus the surveying history before the colonies became states. So maybe 200 to 500 years more before that of where property was divided, and it was all done using a compass. So all those have to be retraced. So we still have to understand and apply declination.
So if we're retracing an old property line, we will need to use it. But if we're taking a new measurement, we might not.
Definitely, if we're doing a new survey, then declination is not really a concern because we're not even working off of magnetic north. We're working off of true north because we're using GPS.
Whereas before that was an impossibility, really.
Exactly. Technology's taken us beyond the compass.
So why don't you tell us some about your own experience? How long have you been surveying in Georgia, and have you noticed the shift in declination since you've started?
Yeah, I started surveying in Georgia in 1984, straight out of college. I'd surveyed a good bit prior to that in West Virginia because my father was a surveyor also. But as soon as I graduated, 2 days after I graduated, I took a job in Atlanta, and I moved down here and went to work surveying. So that's roughly 35 plus years of surveying in Georgia. And over the course of that time, declination has changed roughly 4 to 5 degrees west from what it was when I first started. Declination was real close to being zero in the Atlanta area around 78 to 82 or so, and then starting around 82 it started creeping west, and I'm currently in the year 2021. Declination for downtown Atlanta is roughly 5 degrees, 23 minutes west of true north, so it's constantly moving west right now.
I see. So you have noticed it changing significantly as your career has gone on. It's not just you look back and it's changed, but you notice year to year that it's
Oh,
moving.
definitely. Yeah, definitely. In some years it moves faster than others, so there's no one cycle to it. If you look at the historical data for the Atlanta area, declination was originally, when it was first, I think the first records for the Atlanta area were around 1750. Declination was about 2 degrees east of true north, and it wandered and it kept moving farther east and farther east until it got to about 5.5, 6 degrees east of true north. Then it started wandering back until around 1978 or so, or 1980. It was almost exactly true north and magnetic north coincident. They were almost the same. Now it's constantly moving west.
And now that true coincident line is closer to like Alabama and Mississippi, right?
Exactly. Yeah, exactly. The true line is 5 degrees 23 minutes west of us. So.
Wow. So you mentioned before that surveyors in Georgia do not, or historically did not have to take down the declination on their surveys. What kind of regulations do exist regarding declination in this state?
In reality, there is nothing that specifically states that you have to acknowledge or look at declination. I would say that based upon the fact that current technology alleviates the surveyor from even having to deal with it, since he's using true north instead of magnetic north anymore, that would be the reason that there's no current regulation for it. In the past, I would say that the surveyor was more than likely aware of it and would apply it. It was just not regulated to the point where they had to put it in writing and say, you need to account for this. It was understood that if you didn't, you would perform incorrect surveys.
Okay, so it was a practice in the trade of surveying, but it wasn't enshrined in law, I guess.
Exactly, because it was just understood that
It's
you
just
would do that.
necessary, right?
Yeah.
It's been a good talk. I appreciate you helping me out with this video, and thank you for sharing your thoughts.
You're more than welcome, and thanks to our cameraman, Joe.
Yes, thank you, Joe.
Doing a great job.
Professor Branham was really helpful in helping us understand what declination is, but I wanted more information about how it applies to historical surveys, so I got in touch with Barry Savage. He's a surveyor with over 40 years experience in the Southeast, and he's the manager of survey products at the TVA. He previously had his own surveying business for 10 years, and teaches surveying courses including college courses and continuing education classes for surveyors. He's also an expert on historical surveys, having resurveyed sections of state lines, Walden Pond, and other historical places. So before we get started, Mr. Savage, why don't you tell me a bit about yourself and your career in surveying?
Sure. This actually is my 40th year in surveying. I started in the fall of 1981. First survey was with a transit and chain on the Cumberland River in Nashville, Tennessee. And so I've been surveying for about 40 years, and I did some engineering work for about 5 years as a crew chief, just surveying anything and everything. And you said you're from Dalton. So,
yes, sir, I am. That's my hometown. I've lived there my whole life.
Really? Well, so you're a little familiar with Chattanooga.
Of course, yes, sir.
Yeah, my first big job was Hamilton Place Mall.
Wow, that is a big job.
Yeah, we did all the construction layout for it. So then after I left Whitfield after 4 or 5 years, I went to Chattanooga to work for Cook and Spencer Consultants as their director of production, doing just general survey engineering work, everything from surveying lots to designing cantilever walls to a lot of drainage work, sewers. And then from there, I went to PSI, where we did basically sewers, large regional sewer projects. And then from there in 1993, I started my own business, which I did for 10 years. And I surveyed the Tennessee-Georgia state line, the Tennessee-Mississippi state line. I surveyed for the 96 Olympics. I started teaching. I've surveyed Walden Pond, where Henry David Thoreau lived, with my students. Made a couple of trips to the pond, and then I teach continuing education courses all over the country. In the last 20 years, I counted the other day, I've been in 22 states and 40 cities, mostly
Wow.
boundary law. Boundary law is my favorite thing. I do a lot of expert witness testimony for TVA, and I enjoy being in a courtroom as long as I'm not the one wearing the orange jumpsuit. Then
Sure.
it makes me a happy man. So, and that's kind of it. That's what I've surveyed my whole life. That's all I know.
Absolutely. Well, it sounds like you've had a long and successful career, and I'm glad that you're sharing that experience with me.
We'll see. It's best if you learn from other people's mistakes. So I'll tell you about my screw ups. That's the main one.
Sure thing. I'll be glad to hear it. So what types of surveys that you do cause you to consider magnetic declination?
Well, I do a lot of, or especially when I was in private practice, I did a lot of boundary disputes. And boundary disputes typically arise when old boundaries are hard to find. And the cardinal rule for surveyors is to always follow in the footsteps of the original surveyor.
Mm-hmm.
Not the last surveyor, but the first one that came through. And that could have been in 1890, could have been 1920. So we have to go back, and a lot of people think all a surveyor does is put math on the ground. And what a surveyor does is he or she puts history on the ground. And part of understanding that history is to understand how surveys were done in the early part of this country's history.
Mm-hmm.
And everything was done with a magnetic compass. So all of those surveys have to be put in the proper context. And part of that is knowing how to calculate and use declination to bring it up to something a modern bearing system can use.
That makes a lot of sense because, I just did an interview with my professor recently, and he talked about how, if they do a new survey now that's not, tracing the steps of an old survey, they're using satellites that don't rely on magnetic poles at all. But anytime you're retracing an old survey, you've got to take into account the declination. So do the changes in declination over time affect your work? Like if you go back to a run that you did like 10 years ago, or let's say you want to redo something for the Hamilton Place Mall that you laid out, would the change in declination since then affect that?
It would, as far as surveying the adjoiners. Now, most of the time when I personally get into declination issues, it's usually over surveys that are over 40 or 50 years old.
I see.
Because we've been using, people have stopped using magnetic declination. But Hamilton Place Mall was done on the state plane coordinate system, which would be what your professor was talking about, satellites. And that's on a grid system, and they have a thing called a convergence angle, which is similar to a declination
okay.
angle, but it's a little different. The grid system, the GPS assumes that the entire world is laid out on this perfect Cartesian coordinate system with axes that are 90 degrees to one another, which is actually impossible because lines of longitude. Yeah, and they converge at the top, so there's no way that could happen. So they use what's called a convergence angle. But declination comes into play most of the time. You're right, over old surveys. I don't think in my career, I've probably the first 5 years I did surveys, I used a compass. But most of the time I use a compass as a sanity check, and once again, to try to retrace older surveys that were originally done on a compass. But anything before about 1950 or 40, which I surveyed, I was recently involved in a case where I surveyed deeds in North Carolina back to 1828. So I know that was done on a compass. And so that was when I was analyzing those deeds, I had to take declination into account.
That makes a lot of sense because, surveying in modern times, like I said, it's going to be using those satellites. So can the effects of declination or failing to take those into account have legal or even criminal ramifications? And do you have any examples of that?
Yeah, can they have, I don't know if they have criminal, they could have civil ramifications, perhaps not criminal, because A declination has to do, of course, with the measurements, the angular measurements,
Mhm.
and a large misconception with deeds is, why are measurements even in deeds? Measurements aren't in deeds to establish property lines. They're there to point you to where you can find the evidence on the ground where the property lines lay. If you
Oh,
have
I
a
see.
deed that says, if you have a deed that says north 10 degrees east, 100 feet to a pine stump, let's say, the pine stump is what controls the location. The measurement is just there to direct you to that area. And
Oh,
courts
okay.
have said for years that you only use measurements to replace a corner as a method of last resort. But if you neglect to properly look for that evidence, it can have massive civil ramifications and legal and civil ramifications if you miss finding evidence. So understanding how declination affects your search for evidence is very important.
Right. It's what people talk about when they talk about the corners of a property, like, they're talking about that stump like you mentioned or something like that. So it's not just a measurement. It's a measurement to a physical piece of evidence.
Right. And you just said the magic word. And I tell I teach at a community college also here in town. I teach the survey program here at Cleveland State.
Mhm.
And I tell I actually did a lecture on this last night. And that is when you look at a deed and it says north 10 degrees east, 100 feet to a stump. And then it says, south 45 degrees west, 200 feet to an iron pipe. Most people don't know the most important word in a deed is the word to. Because when you see the word to, when you read a deed, you need to key on that word. Everything that comes after it is locative, and it's what controls. Everything that comes before it is just directive. It just directs you to an area. So that word to separates everything that's after it is actually what you're looking for. And once you find that thing you're looking for, the stump or the pipe, then the measurement no longer matters. But
That
you
makes
have to
sense.
know how to properly use those measurements to find that evidence.
Sure. So you mentioned that you've done some historical surveys. What are some of your favorites that you've done?
Yeah, probably the first one I did the Tennessee-Georgia state line. There's been a contention over that since it was originally surveyed in 1818.
Really? I didn't know that.
Yes, there was a murder case there was a man murdered in Copper Hill, Tennessee, and there's a blue line that goes through town. And he was, when he was killed, he fell right on the line. And they didn't know whether to try him in Tennessee or Georgia. He was stabbed behind a bar. That happens a lot in Copper. If you've never been to Copper Hill, Tennessee, that's pretty common. So, but
I'll take your word for it. I've never been there myself.
it can be a rough place. But that line was originally laid out in 1818 by a man named James K. Mack, who was a mathematician from the University of Georgia. And a few years later, he found out that it was off by a mile. It was a mile too far to the south. And people today say, well, how could you get off a mile? Well, James K. Mack asked for an instrument called a zenith sector to lay it out, which that's the same kind of instrument that Mason and Dixon used to lay out the Mason and Dixon line. And that line's only off 900 feet. But that instrument, you have to lay on your back and you read angles to the stars. And then you do spherical trigonometry, because the state line between Tennessee and Georgia was the 35th parallel of latitude. So what James K. Mack was left with doing is he had to use a mariner's sextant. Do you know what that is? It's
I don't know. Never heard of that.
You read an angle from the sun down to the horizon, and then you subtract that from 90 degrees, and then you add or subtract your declination, which is how far the sun is in the sky from the equator, and it gives you your latitude. But
Okay,
it's only close to within about a mile. And it has a lot of drawbacks. It only works at high noon when the sun
you can only survey once a day.
Yeah, you can only find that. That's right. You can only find that latitude once a day. And then you have to run the rest of it with a compass and take declination into account to stay on that line. And secondly, remember, this works from reading an angle from the sun down to the horizon of the ocean. Well, in the mountains of North Georgia, there is.
Yeah, you're not going to be able to see that.
Right. So they have a device called a artificial horizon, but because that isn't a direct measurement, it's just another place for error.
Right.
So they, that's how that line got off. And then I surveyed the Tennessee-Mississippi state line, and it got off pretty much for the same reason. I've done a lot of work on the Tennessee-Kentucky state line, and it's off in some places up to 6 miles.
Wow, that's a lot.
Peter Jefferson, Thomas Jefferson's father, started that, and it wasn't Tennessee and Kentucky at the time. It was North Carolina and Virginia were the states that were involved. And there's a book called 4 Steps West that has all the original field notes from that survey, and I've went back and reproduced those.
Wow, that is really cool.
I surveyed, I took my students in 2003 to Walden Pond. I guess, do you know who Henry David Thoreau is?
Oh yeah, I read a lot of him in high school.
Yes. Walden and A Life Without Principle and Civil Disobedience, all of those. Well, a lot of people don't know he made his living as a surveyor.
I didn't know that.
Yes, his writings didn't become popular till the early 19th century. So I got hooked up with the Thoreau Institute, and we went to Walden Pond. And when he wrote his book, Walden, he was living on Walden Pond. Well, Ralph Waldo Emerson actually owned the pond. Thoreau surveyed it for him. And we went back and found 2 of his original stones that he set in 1848, 49. We uncovered the 2 stones that he originally set. And then what we were trying to do, if you've read Walden, there's a long dissertation in there about the bean field. And that was at Walden. There was a academic debate as to exactly where the bean field was. There were 2 possible locations, and we came in and surveyed the area and topoed it to give them more evidence to try to figure out where it was at. And so, and I've been to the pond a couple of times. And so,
did you find anything conclusive about where it might be?
Actually, it's funny you should say that. They argued about it. There's 2 possible places. There was one on the front side that seemed more likely than the one behind the old cabin site. And so we got the dimensions to fit on the one on the front side. And then in one of Thoreau's essays, I believe it's Life Without Principle, he describes working in the bean field and watching a man drag a rock down the old Concord Road to take to another, to a rich patron in town, that he was going to use it as a patio table. Well, then it dawned on me, the only place you could see the old Concord Road was from the front field.
Well,
so
there you go. Sounds like
that had to be it. So it wasn't the measurements that showed the evidence that we needed. It was the qualitative part of Thoreau's description. And it's the same way with the deed. When you read a deed and it says north 10 degrees east, 100 feet to a stump, well, the stump's what you're looking for, the qualitative thing, not the measurement part. And that's why I like surveying so much, because the logic that's involved in trying to put the evidence together, and understanding that all of this, that the legal principles that are involved can trump all your measurements in a split second.
Before we go, is there anything else you'd like to share about surveying, about declination, about anything that we've talked about?
Like I said, the main thing is understanding, especially if you're going in this profession, or of course, I understand that a lot of you aren't, or if you're going to be working with this profession, to understand that when you work with a surveyor, with a good surveyor, especially doing boundary work, to understand that measurements aren't the do-all, be-all, and end-all of what we do, and that GPS is a wonderful tool, but it doesn't answer the legal questions that are actually the bedrock of what we're trying to do, which is where was the original boundary, and that's where your declination comes in. That's putting that history together is why that's so important.
Well, thank you so much for coming to help me with this project. I've had a lot of fun learning about surveying, and making a video like this is not something that's really in my wheelhouse as a civil engineering student, but it's good to get more experiences and talk to people like you who are in a different field than what I aim to be in at some point. So thank you for sharing your thoughts and experience with me. I really appreciate it.
No problem. Well, if you're going to be a civil, you're going to be working with lots of surveyors. So
That's right.
Getting to know how quirky we are would be a good thing.
Yes, sir. Point taken. But yeah, thank you, Mr. Savage. I appreciate your time.
All right, Lawrence, talk to you later.
Yes, sir. Bye.
Bye.
So what have we learned about declination? While being a very old concept, declination still is very important with regards to historical surveys and boundary disputes. Precision is very important in the field of surveying, so even slight errors when accounting for declination can cause large issues. Declination even has legal ramifications regarding the boundary lines between properties or states. Finally, declination is constantly shifting, so surveyors have to remain aware of its changes. I hope that this video has been helpful in understanding what declination is and how it applies to the field of surveying, both in the past and today. Thank you for watching.